Anybody got a mechanical pencil? I need a pencil.
I have a pencil. I have a couple pencils in that. Okay, this video is going for my 7th hour, just so you know I'm teaching 5th hour right now. Okay, so if it's loud, turn the volume down. If there's weird pauses, it's because I'm out helping students and stuff, but should be pretty smooth. Okay. All right, we've got a couple what we call postulates that are going to help us with some geometry stuff today. First of all, I want you to point to the word postulate or write down the word postulate. And write down the following. A postulate is a rule that we accept without having to prove it. Without proof. This is nice because a lot of times in math we have to prove what we say, but in geometry there's a ton of stuff that we accept in our world without proof. Here's another thing we accept. 1 foot is 1 foot. You ever thought about it, like who created measurement? Long time ago, Greek mathematicians started to create measurement, but we just accept it. We accept things without proof a lot. So these 3 things today that I'm going to teach you are accepted without even having to dive into the why. It's kind of nice. Okay. Here's the first one. It's called the linear pair postulate. It's pretty smooth. If I draw a line, how many degrees is one line straight? 180. Good job. Okay. 180 degrees. Ooh, somebody said 0, which honestly, you could argue that there is no angle there. That would only be if there was one ray. If there was one ray, that would be a 0-degree angle. With a line, this opens up to be 180 degrees. So now, here's what a linear pair is. If you took a line and you broke it into 2 different angles, okay, and it would look like this. Okay, go ahead and draw me a picture of just a straight line broken into 2 angles. Angle 1 there, angle 2 there. Okay. Now, because both of these create this line, what would both these angles have to add up to? You've already said it. They would have to add to 180. By the way, you're already 1/3 done with your notes. That's called the linear pair postulate. Let's write that down. The thing about it, though, is straight lines are obviously everywhere in 2 dimensions and 3 dimensions. So we talk about this quite often in geometry. The linear pair postulate, which I will abbreviate LPP, says if 2 angles, remember this is going on YouTube. Don't do that. Yeah. If 2 angles are a linear pair, if 2 angles form a straight line, aka a linear pair, then they are supplementary. Oh, is that I don't know if you guys know that word or not, but we know it. If you didn't know it, you know it today. Okay. If 2 angles are a linear pair, they have to add to 180. Obviously, the root word there is line. They add to 180 degrees. Okay. So here's what this helps us with. Again, very, very common when we have straight lines and lines intersecting. Okay. Bless you. So watch this. If you have 2 lines that intersect in like this fashion right here. Okay. Go ahead and do that. Just honestly, any 2 lines intersecting really in any sort of way you'd like. But let's make one angle in here 50 degrees. If that's 50 degrees, look at where I put this green dot right here. See what your mental math is like. What would the green dot's angle be? If 130. Good job. Well, Brandon's pretty bright. But also because what did we just say? A linear pairs are 2 angles that form a straight line. Would you agree these 2 angles form a straight line? So they have to add to 180. So if you know one of them, you just do some subtraction. Okay. Now let's talk about this angle right here. What would this angle be back to? 50. which means that the ones across from each other are the same. Look at the 50 and the 50. It's kind of like how scissors open and close, right? If one angle gets bigger, the other gets bigger. Ah, the other one's 130, you studs. Good job. Great job. Okay. So now, linear pair postulate. That is as easy and tough as it's going to get. If you have two angles and they form a straight line, they add to 180. Now on Monday, we'll get into some algebra if I put in a couple equations in here, but we haven't done a ton of algebra yet. So today it's just the geometry concepts of it. Okay. Questions on linear pairs. Super simple. Let's go on to number 2. Number 2 is called the angle addition postulate. It's actually super similar to what we just learned. Angle addition postulate. Yep, AAP. Sorry, no, nothing you can make any jokes out of there. I know. Sorry. Okay. Here's what the angle addition postulate says. It actually says it doesn't really matter if it's a straight line or not if you have two angles that are connected. And by connected, I mean they literally share one of the rays. Okay, so you have like angle 1 here, angle 2 there. Okay. You are. Okay. Oh, I would love. Don't think this is the video that's going to do it, though. Okay. Let's say this is, let's say that's 40 degrees, angle 1 in there. Okay, if that's 40 degrees. And let's say the angle number 2 is 80 degrees. Actually, that would be bigger. Look at angle 2. It's already bigger than 90 by itself. I better at least be realistic in my video since it's going viral, you know. Probably be closer to 100. Okay. Now, these don't form a straight line. Obviously, they don't add to 180. But what the angle addition postulate says is if this is 40 and this is 100, then the entire angle from the bottom here all the way through there is what number? 140. You can add them together. It's as easy as saying this. Measure of angle 1 plus measure of angle 2 is equal to the whole thing, which is 140 degrees. You literally add the two angles together. It's unbelievably easy, but we use it so often in geometry that we have to at least take a day to say this is legal to do. But here's the thing, they have to be connected. If they're just kind of chilling to the side or whatever, then you don't have a full angle to measure. But they have to be connected here with one of the rays. Okay, let's see how smart you are before moving on to the last one, and then we're already pretty much done with our lesson, 2/3 way done. Okay, let's say I have one angle and it's got a box there. What's its measure? Great job. Let me throw another ray in here. I have other colors, which you might not, but I'm just going to do it just so my drawing's not so cluttered. If you throw that in there and let's say that's 20 degrees, just inside of this little piece right there, and I ask for this remaining piece. True or false? We'd go 90 plus 20, and that would be 110. Very good. We would subtract. We're already given the whole part, and we're given the smaller part, so we would subtract, and therefore the remaining piece would be 70 degrees. Great job. What you guys just did is use the angle addition postulate. You just figured out we had a whole and a part, and you subtracted. Great job. How's the difficulty level so far? Feel all right? You guys are going to do, you're going to do unbelievable on this. Okay. Lastly is called the segment addition postulate. Also, nothing we can make a joke out of. SAP, I guess. Yeah. Okay. Now I'm going to give you a true or false question. Don't jump the gun. I think you'll get it right, though. Let's say you start out at Millard North. And how many walk home? Anybody walk home? Oh, you can? Okay. Let's say you walk down Pacific Street to the gas station. Yep, that's like 5 blocks. Okay, now watch this. Now you go into the neighborhood and you go this direction to your friend's house, right? And that is 3 more blocks. Okay, now I'm going to ask you a true or false question. The distance you just traveled in a straight line from Millard North to your friend's house, if you had to measure this in a straight line, that would be 8. True or false? Ooh, good job. The answer is false. Okay. So let fill in the blank. Oh, go ahead, Mallory. A block. Ooh, this is a good. How many? No, let's talk about this because we actually asked this last. This is good to know. How many blocks are in 1 mile? Do we know? I'll give you a hint. 132nd Street, 144th Street, 156th Street, 168th Street. Do you ever notice that all those streets that are pretty important in West O? It's 12. So because 12 blocks is 1 mile. No, 12, 1 block is not 12 miles. No. But have you ever noticed that all those streets are 12 apart? That's because in theory, 12 city blocks is 1 mile. So 12 blocks is 1 mile apart. So to 156th Street in theory is 1 mile. Okay. So fill in the blank here. Fill in the blank. You listen. The closest distance between 2 points is what? The closest distance between 2 points is a straight line. So if you go 5 and 3, this is not 8. It should be less than 8 or greater than 8. Less. If you've gone 8 blocks going in a different direction, then it should be less to go right from Millard North to your friends. But Mr. Hers, what if we have to go through bushes and stuff? Well, yeah, sometimes if you want to go less distance, you got to take the tough terrain. Okay. So now, what does the segment addition postulate say? All right, I'm going to show you. Let's get this triangle out of the way. Let's say you're going from Millard North down to the gas station, and now you just continue going in a straight line. All right. And your friend lives right on Pacific Street. Okay. Now you've gone 5 blocks and 3 blocks. And now how many blocks is it to your friend's house? 8. Why? Because you have continued in a straight line. So here's what the segment addition postulate says. Okay. Write this down with me. If G is between, meaning on a line segment, M and F, if G is between M and F,